Good morning all. Myself is Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering. So this is a serious video and I have previously posted videos on sequential circuit with basic flip-flops, counters and registers, and today we are going to discuss on SR flip-flop. So this comes under the subject Digital Principles and Computer Organization. So basically, what is a flip-flop? It is an electronic circuit with two stable states that could be used to store a one bit of information, right? And this bit of information is stored upon the clock pulse, right? So each and every time when you give the clock pulse, the flip-flop will be able to store the one bit of information, and this is the basic building block of any digital electronic system, and this has been implemented in computers, communication systems, and since other control systems also. Here the diagram given is a basic of an SR flip-flop, which is a set and reset flip-flop. So as I previously said that flip-flop will be triggered on the clock pulse given, right? So that clock pulse could be on edge triggering clock pulse, which means when it starts to rise from a low to high, the count will start to occur. We say that as a rising edge, and the falling edge is the vice versa when it starts to dip from high to low. So based on the edge triggering also the flip-flop will be triggered. So what are all the type of flip-flops? Set, reset flip-flop, delay or D flip-flop, toggle or T flip-flop, and jack kill by flip-flop. So these are the different types of flip-flop, and today we are going to discuss on the SR flip-flop in detail. As I said, SR, it stands for the set and reset flip-flop, where the set and the reset condition, based on the inputs on these two conditions, it is able to control the output state. Here we mention it as a Q, right? What are all the different states that exist in the SR flip-flop? Whether the both set and the reset both are occurred zero, which is 0 0 condition, we say that as a no change, which is it hold what remains in the previous state. Since the sequential circuit consists of a memory, so it is able to know what will be the previous state also. Hence, under the 0 0 condition of a SR flip-flop, we refer that as a hold state, which means both S and R in the low state, it retains whatever the value that exists in the flip-flop memory as such. The next condition is the reset state. When S is equal to 0, R is equal to 1, we say that condition as a reset state. Reset means whatever the condition has been given, it clears that state and makes it to 0. So here the output always goes to 0, and this is the reset operation. So when reset is high and set is low, the output always gives the clear condition, which we say that as a reset operation. The next one is a set state. When set is high and reset is low, that is S is equal to 1, R is equal to 0, and this is we categorize as a set state, which means the output Q will be given as a 1. And the last condition is forbidden state. Forbidden state is that state does not exist here in the case of a SR flip-flop. That is, when S is equal to 1, R is equal to 1, when both the flip-flop are being high, that is the set state and the reset state both are high, we say that as a forbidden state, which is not possible, right? Which is both Q and Q bar, it attempts to go low, which results in an indeterminate state, and the state should be avoided here in the case of an SR flip-flop. So here you could see the symbol of an SR flip-flop and the circuit diagram implemented using the NAND logic, right? So the set pin and the reset pin will be triggered upon the clock pulse given, and the output is one is Q, the other one is a Q bar, right? Here the circuit have been implemented using the universal gate, which is a NAND gate. This could also be implemented using the NOR gate also. And here we could see the truth table of SR flip-flop. So the Qn denotes the previous state and Qn plus 1 denotes the next state. So under the 0 0 condition, whatever value in the previous state that retains in the present state, and hence it is no change. So when the Qn is 0, the next state is also 0. When Qn is 1, the next state is also 1. So this is no change condition when S is equal to 0 and R is equal to 0. The next one, when reset is being given high, that is S is equal to 0, R is equal to 1, we say this as a reset state. So in the previous value of Qn, which is Qn, whether it could be 0 or 1, whatever it is, the next state will be 0, right? That is what we say as a reset state. And the next is 1 0 condition, which is set state. Whatever the value is present in the Qn, either it could be 0 or 1, whatever it is, the next state will be set, that is 1. And 1 1 is the indeterminate state. So whatever value exists in Qn, the next state will be x, which is the indeterminate state, right? And when no inputs are being given, it is not activated based on the clock pulse, then also it has a no change, right? Whatever the value exists in the previous, that will retain here. The characteristic equation based on the truth table for the SR flip-flop is Qn plus 1 is the next state, which is equal to S plus R bar Qn. So this is the characteristic equation of the SR flip-flop, excluding the 1 1 condition, which is an indeterminate state of the SR flip-flop. So applications of flip-flop we have been used in registers, frequency dividers, and digital counters. So in SR flip-flop, the output becomes invalid when S is equal to 1 and R is equal to 1. The stable state of an SR flip-flop is stored in the output terminals Q and Q bar. So kindly refer my previous videos. Thank you.